Welcome. So we're going to look at vectors and scalars in this video. Now, vectors and scalars are an important distinction from measured quantities in physics and all sciences. Some of the measurements you will take, or some of the units you'll be given, measurements you'll be given are vectors and some are scalars. What are the difference between these types of measurements? Well, vectors, use a different color. Are measurements that use both magnitude and direction. What do I mean by that? Well, direction is important for certain measurements in physics, like displacement. If you displace an object, you move an object, which direction you move it is important. Did you move it up or down? Did you move it left or right? Did you move it forwards or backwards? Or some combination of those. Velocity is a vector in physics. It's very important. Driving 20 miles an hour north gives you a different result than driving 20 miles an hour south. It changes the displacement differently. You end up in a different place if you drive 20 miles an hour north versus 20 miles an hour south. Forces, which we won't get into for a while, but forces are vectors. Direction is important. If I push you one way or pull you, the force I apply on you, the direction, changes the outcome. If I push an object up or down, left or right, it changes depending on the outcome. That is an important difference. So examples of vectors would be displacement, velocity, we're going to learn about acceleration, forces, and so on. These are all examples of vectors. Now, vectors are probably most easily understood when we contrast this with the idea of scalars. What is a scalar? This is a measurement or quantity with only magnitude. And no direction. So some examples of this, temperature, right? Temperature, when someone asks you what the temperature is, you don't have to give them a direction. In fact, that's nonsensical. How warm is it in this room? Well, it's 70 degrees Fahrenheit up. Or it's 22 degrees Celsius east. That makes no sense. So distance traveled is another scalar quantity, right? It doesn't matter, direction's unimportant. If you look at the odometer on your car, the odometer on your car doesn't care what direction you're traveling as it scrolls up. Other energy, right? When you read the calorie content on a sandwich that you're going to eat or a carton of yogurt, it's not 120 calories north. It makes no sense. So there are some quantities, like scalars, again, examples are temperature, energy, pressure, distance, speed. I think speed went off the end of the video there, but speed, are just some examples. These aren't exhaustive lists, but there's some examples of the difference between scalars and vectors. In kinematics, when we talk about motion, direction is important. There'll be some times where we talk about energy or pressure, where direction is not important. And some problems are easier to solve one way, some problems are easier to solve the other, and we'll learn about that later on this semester. So the difference between scalars and vectors in your textbook is that vectors will usually be represented either as a bold letter or with a little arrow above it. So a vector example, velocity. Velocity with a little arrow above it, or a little half arrow, see the little tip here has a little arrowhead on it, is a vector. Acceleration is a vector. Displacement is a vector. Now, compare and contrast this to scalars, where since we will learn speed, or I should say we have learned, distance is just the magnitude of the displacement. So distance would just be delta x. Displacement is delta x with a little arrow above it. Now this can sometimes be confused with average, and we'll talk about average velocities in the next video. Average, your book uses a little bar above the variable to represent the average. That bar, you'll see, doesn't have a little arrowhead on it. So that's the slight distinction between an average speed, for instance, and a vector. Now, it's unfortunate they do that. Not many books do. I like using a little subscript average to show that it's an average, but not everyone does it that way.